Hi, welcome to NPA teaching. Today we are going to introduce the concept of integration. Differential calculus is centered on the concept of the derivatives. If a function f is differentiable and then its derivative f prime exists, then naturally a question arises that given f prime, can we determine the original function? That is, differentiation measure the rate of change of a function, but frequently in economics, we know the rate of change of a function and we want to find the original primitive function. The inversing the process of differentiation and finding the primitive or original function from derivative is called integration or anti-differentiation. The development of integral calculus arises out of the efforts of solving the problems of finding a function whenever its derivative is given, and the problems of finding the area bounded by the graph of a function under certain condition. These two problems leads to the two forms of the integrals, that is indefinite and definite integrals, which together constitutes the integral calculus. As we are already said that there are two forms of the integral calculus, that is indefinite integral and definite integrals. Indefinite integrals are defined without upper and lower limits. It is represented as indefinite integral of f with respect to x dx, and the function f of x is called the integrand. On the other hand, an integral that contains the upper and lower limits, then such a integrals is called definite integrals. So a definite integral is denoted by a definite integral from a to b f of x dx, where a is called lower limit of the integral and b is called upper limit of the integrals. Thus the definite integral has a unique value. Given f of x is the original function and the derivative of the function f of x is the f prime of x. As we said that the integration is the inversing process of differentiation and finding the original function from its derivative. Now see here, we are going to introduce a new symbol to find the original function from its derivative f of x, which we read as indefinite integral of f with respect to x, which will represent the entire class of antiderivatives. Symbolically, we can write the indefinite integral of f with respect to x is equal to f of x plus c. Given the derivative that dy dx is equal to f of x, which is the first derivative of a given function, and if we want to find the original function is the y. So if you want to find the original function, then the y is equal to the indefinite integral of f with respect to x. In the given table, for the simplicity, we are taking the symbols or terms or phrases with their meanings. So here the first one, which is the integral of f with respect to x. Here the function f of x in the integral, which is known as integrand, and the x of f of x in the integral of f with respect to x is the variable for the integration. For example, the integral of 2x dx. So here this symbol for integral, which is a stylish s, where s is for sum, the idea of summing of slices. After giving the integral symbol, we put the function we want to find the integral, which is called integrand. So here 2x is the integrand, and then finish with dx, which means that the slices go in the x direction and approaches to 0, which simply it is a variable of integration. And here see how we write the answer. So integral of 2x is equal to x square plus c. How we got the answer we'll discuss in the next video. So what do you mean by c? That is, we wrote the answer as x square plus c. But why we wrote plus c? It is the constant of integration. It is there because of many functions whose derivative may be 2x. For example, the derivative of x square plus 4 is equal to 2x, and also the derivative of x square plus 100 is equal to 2x. It may be x square plus 50, which is also is equal to 2x, and so on. Because the derivative of a constant is 0. So when we reverse the operation, that means when we find the integral, we only know 2x. But there could have been a constant of any value. So we write up the idea by just writing plus c at the end. I hope you are clear about the introduction to integration. In the upcoming videos, we will discuss the rules of integration. Have a nice day and see you in the next video. Thank you.